Those perfect red tomatoes on ketchup bottle labels are nothing like the varieties used in mass production. Harvested early and artificially ripened with ethylene gas, these industrial tomatoes begin a journey through production lines that process 300,000 pounds hourly, roughly the weight of 100 cars, transforming ordinary produce into America's favorite condiment through surprisingly complex methods. The secret tomatoes you've never seen. Ever notice how tomatoes on your vine look nothing like what ends up in your ketchup? Those juicy, flavorful garden tomatoes would actually make terrible ketchup. The tomato industry operates a parallel universe of tomatoes specifically engineered for processing, not eating. Commercial ketchup starts with specialized processing tomatoes that bear little resemblance to those plump red fruits on product labels. These industrial varieties function like high-performance engines designed for a singular purpose: maximum processing efficiency. They contain up to 30% more solids, significantly less water, and feature thicker skins with concentrated flavor profiles. While perfect for reduction into paste, they'd be absolutely disappointing on your sandwich. Too firm, less juicy, and borderline unpleasant when raw. Surprisingly, these tomatoes are harvested while still partially green and hard. This makes perfect sense in industrial context. Firmer fruits survive mechanical processing better and continue ripening during transport, maximizing both durability and flavor development by the time they reach processing facilities. Harvesting. Fields become factories. Modern tomato harvesters are engineering marvels that process up to 70 tons hourly. These aren't simple picking machines. They're rolling quality control centers equipped with electronic color sensors that analyze each tomato in microseconds. The technology detects subtle ripeness differences and identifies defects invisible to human eyes, automatically rejecting unsuitable fruits before they leave the field. Any tomato that doesn't meet exact specifications gets ejected and returned to the soil as compost. The journey after harvest would horrify produce managers at grocery stores. Unlike carefully stacked displays, processing tomatoes are unceremoniously dumped into massive trucks without boxes, crates, or protection. They're piled like gravel, often getting crushed in the process. For processing varieties, appearance became irrelevant the moment they were picked, much like how a race car's paint job matters little compared to engine performance. Time becomes critical immediately after harvest. These tomatoes must reach processing facilities within hours, creating a logistical operation rivaling automotive just-in-time manufacturing. During peak season, trucks create lines stretching for miles. Any delay risks fermentation in summer heat, potentially ruining tons of product. At factory gates, every load undergoes rigorous testing. Quality control technicians measure exact sugar content, Brix levels, check precise acidity ratios, and scan for contamination. A single failed test can cause entire truckload rejection, standards as strict as any automotive assembly line. The industrial breakdown process. Once tomatoes plunge into the processing facility, they're subjected to treatment that strips away any resemblance to recognizable fruit. Water flumes serve as the first stage, with powerful jets blasting away field dirt and agricultural residue while simultaneously scrubbing and sanitizing. Next comes thermal shock treatment, the engine starter of the entire operation. Massive hot water baths and steam chambers blast these fruits with temperatures between 180 to 200 degrees Fahrenheit, comparable to what your car's radiator handles during summer highway driving. This extreme heat loosens tomato skins and breaks down cell walls, preparing them for complete breakdown. Heat-treated tomatoes feed directly into industrial pulping machines with rotating blades that process up to 400 pounds per minute, transforming firm fruits into uniform slurry in seconds. The sound rivals standing next to a diesel truck with failed mufflers. Workers wear ear protection as standard equipment, not optional gear. The resulting tomato slurry enters an extraction system separating valuable components from waste. The pulp forces through specialized screens with increasingly fine mesh sizes, functioning exactly like automotive filtration systems. These screens trap seeds, skins, and fibrous material while allowing juice and fine pulp to pass through. Extraction continues through massive centrifuges, spinning at thousands of RPM. The same principles used in fuel purification systems. Heavier seeds and skins fly outward for removal, while valuable juice moves toward the center for collection. By this stage, the tomato exists only in liquid form, completely deconstructed. This concentrated juice still contains too much water for efficient shipping or storage. Enter the vacuum evaporators, engineering marvels that remove up to 80% of water content while preserving flavor compounds. Operating under vacuum conditions to lower water's boiling point, the process transforms gallons of tomato juice into thick, intense paste, the foundation for ketchup production. Throughout this transformation, continuous quality testing occurs. Inline sensors monitor brix levels in real time, while automated sampling systems check pH, viscosity, and color values. Sophisticated analyzers scan for contaminants down to parts per million, ensuring nothing unwanted survives the process. Quality control that matches automotive safety standards. The secret formula: more chemistry than cooking. That concentrated tomato paste forms the foundation of ketchup, making up about 60 to 70% of its composition. The remaining 30 to 40% contains carefully calculated ingredients that ensure the ketchup you squeeze onto your burger tastes exactly like the one that accompanied your childhood French fries. Sweeteners serve as the cornerstone of ketchup's consistent flavor profile. While traditional recipes used simple sugar, today's manufacturers primarily use high-fructose corn syrup or corn syrup for production consistency, extended shelf life, and signature sweetness. Each tablespoon contains roughly 4 grams of sugar, equivalent to a teaspoon of sugar in every 4 tablespoons you consume. The tangy kick that makes ketchup instantly recognizable comes from a meticulously engineered acid profile. Vinegar delivers the primary tang, supported by precisely measured amounts of acetic acid, citric acid, and sometimes malic acid. Together, they create a specific pH level between 3.5 and 3.9, essential not just for mouth-watering tanginess, but for preventing bacterial growth during long-term storage. Salt plays a crucial role beyond enhancing flavor. A single tablespoon contains approximately 190 milligrams of sodium, more than many potato chips. This significant salt content serves as a preservative that contributes to ketchup's impressive shelf stability. The signature flavor we all recognize comes from proprietary spice blends varying by manufacturer, but typically featuring onion powder, garlic powder, allspice, cloves, cinnamon, and celery salt. These spices are dispensed by computerized systems measuring down to fractions of a gram, ensuring the ketchup on your table today tastes identical to last year's version. Texture agents create ketchup's unique flow properties. As a non-Newtonian fluid, ketchup remains thick in the bottle but flows when pressure is applied. Thickeners like xanthan gum and modified food starch control viscosity with remarkable precision, preventing the separation of solids and liquids that plagues homemade versions. Precision manufacturing, mathematical consistency. When tomato paste enters the final production phase, it flows into industrial mixing vessels larger than most swimming pools. These stainless steel behemoths hold over 10,000 gallons of product, enough for 160,000 standard ketchup bottles from a single batch. Inside these tanks, ingredients aren't measured in cups or teaspoons, but by carefully calibrated weight percentages. Sweeteners, acids, salt, and spice blends enter in specific sequences at precise intervals. The mixing technology creates perfect consistency through high-torque industrial agitators with 6-foot blades that create controlled vortices, ensuring uniform distribution without excess air. Throughout the process, a sophisticated sensor network monitors over 50 different parameters with remarkable precision. Viscosity meters track thickness to within 0.1% accuracy. Brix analyzers continuously monitor sugar content, while pH probes maintain acidity at exactly 3.65, plus or minus 0.05, the perfect balance between tangy flavor and food safety. After mixing comes homogenization, the secret behind ketchup's perfect consistency. The mixture gets forced through specialized valves under extreme pressure up to 2000 psi. This intense pressure breaks down all particles to microscopic size, creating a stable emulsion where components remain suspended rather than separating. Bottling. NASCAR speed meets surgical precision. The bottling line is where food manufacturing truly mirrors automotive assembly plants, combining blazing speed with microscopic precision. Before a single drop enters a bottle, the product flows through ultra-fine mesh screens that trap any remaining particles that might affect texture. Empty bottles race through synchronized machinery spanning up to 60 feet. Bottles flip upside down as compressed air blasts at 80 to 100 psi, clearing manufacturing debris before sterilization occurs through superheated water jets or hydrogen peroxide mist. The filling station showcases engineering mastery at full throttle. Modern machines use volumetric pistons or magnetic flow meters to dispense ketchup with plus or minus 0.2 gram accuracy, about the weight of a grain of rice. A single line processes 800 to 1200 bottles per minute. Bottles blur into a continuous stream, each receiving its precise ketchup portion in milliseconds. Bottles zoom to capping stations where automated systems apply closures with precisely controlled torque, typically 15 to 20 inch-pounds. This creates a hermetic seal tight enough to prevent spoilage, yet consumer-friendly. Throughout this high-speed choreography, inspection systems maintain vigilance. HD cameras capture 100-plus images per bottle, analyzing fill levels, cap position, label placement, and date codes. When defects are detected, pneumatic diverters activate within 50 milliseconds, faster than your car's airbag deployment system. The scale impresses most visitors. A typical ketchup line stretches over 300 feet, with bottles completing this journey in under 5 minutes. At peak capacity, a single line produces up to 72,000 bottles hourly, enough to fill nearly 100 shipping pallets daily. The hidden marvel in your kitchen. From those ordinary-looking tomatoes ripening in sun-drenched fields to that familiar red squeeze of sauce on your plate, ketchup manufacturing represents one of food production's best-kept secrets. What appears simple is actually a masterclass in precision engineering that rivals the sophistication of an automotive assembly line. Consider the journey. Millions of tomatoes must be sorted, processed, and transformed with absolute consistency. Every single bottle that leaves the factory floor, whether it's destined for a diner in Detroit or a restaurant in Dubai, must deliver that exact same tangy, sweet experience. This isn't cooking, it's industrial choreography orchestrated by sensors, computers, and machinery working in perfect harmony. The parallels to automotive manufacturing aren't coincidental. Both industries obsess over repeatability, quality control, and efficiency. Just as a car manufacturer can't afford to have one vehicle's steering wheel feel different from another's, ketchup makers can allow batch-to-batch variations. The same principles of Six Sigma quality control, just-in-time manufacturing, and continuous process improvement apply whether you're bottling condiments or building cars. The technology hidden inside these facilities would astound most consumers. Viscosity sensors measure thickness to within microscopic tolerances. Computer vision systems inspect every bottle at superhuman speeds. Robotic systems handle products with a gentleness and precision that human hands could never maintain hour after hour. The control room monitoring a ketchup production line looks remarkably similar to one overseeing an oil refinery or semiconductor plant. Next time you grab that bottle from your fridge, take a moment to appreciate the engineering marvel in your hand. That perfect squeeze, that uniform color, that consistent taste, none of it happened by accident. Hundreds of engineers, Food scientists and manufacturing specialists collaborated to ensure your experience would be identical to the last bottle and the one before that.